All right, we're going to go through this. So this is concepts. These are not specific examples. Specific examples are going to be on the PDF that I assigned, okay? I posted the key to the PDF, so I want you to check your answers, obviously, over the weekend to help you out. But I would not recommend opening up your answers and doing question by question and then checking it and giving yourself like that false sense of security that you already know the answer, okay? Wait, I would say complete it, then check it, okay? So we started at the beginning with 1-1 and 1-1 and 1-2 were on your quiz, okay? And we just talked about which ones are going to overlap. For 1-1, independent variables, remember independent is what you're plugging in, that's your X or your input. Dependent is what you're getting out of it, the Y or the output. You are describing that in words, okay? So not necessarily not variables, but words if it says it. And you also from a graph, so the big question on your quiz that asks for increasing, decreasing, concave up, concave down, X or zeros and Y intercept. You'll have one question like that where it's got multiple parts. In 1-2, that's where we started rate of change, okay? And we started with rates of change from coordinate points, from a graph, from a table, and from an equation. There are two different kinds of questions from an equation. One in which they give you the interval. So if I gave you an equation and I said put it on this interval, you would literally plug in those two values and then do f of the second over f of the first minus the interval. And then the other time where it didn't give you an interval and so you have to plug in values. So if I said find the rate of change or the average rate of change of f of x equals, we'll make this easy just so that we can do this quicker, but notice it could be complicated. On the interval of -2 is less than x, which is less than 1. So if it says, again, if it says the interval, then I'm going to do f of 1, the second one, minus f of -2 over 1 minus a -2. And then I would plug them in. F of 1, plug it in, I'd get 3 minus 1, which is 2. F of -2, 3 times -2, -6, minus 1, which is -7, over 1 minus a -2, which becomes 1 plus 2. And this would be -5/3. It's going to ask you, if you are on the calculator portion, to round that to the nearest hundredth, because we're going to do that from here on out. Okay, we assume hundredths. So I would actually, that would be like 1 2/3, right? So this would be -1.667 if I was rounded. If it's on the non-calculator portion, then you can leave it like that. If it's on the calculator portion, it's going to say round it. So you got to give me the decimal. If it doesn't give you the interval, so if this whole question did not give you the interval, then this is where you're going to plug in values to find your rate of change, okay? I would, again, plug in the values that are actually, that would happen on the rate of change of the rate of change. So it won't happen on your regular rate of change. Rate of change is going to give you your interval just like that, okay? Now this equation can be complicated, and in that kind of question, it would be calculator based. So you can plug in your y equals, and then you remember you can go back to that menu, the alpha y equals, and the alpha calc trace button, and it will bring up your fraction, excuse me, and I would write it in like this. So first you're going to put in the f of whatever underneath your y equals, and then you would type it in like that. That's the easiest way to do it. You want to be comfortable doing that on the calculator because that will save you a lot of time. When we get done with the notes, we can go back to that if we've got time, and we'll walk through a question like that. And then obviously without the interval, this is where you would be plugging in points. So you would, but it would, that will happen for, I shouldn't have put that there, sorry. That would happen for the average rate of change, or the rate of change of the average rate of change. From a graph, you will literally just pick some points, and it will either tell you, it will give you the 2 points, you'll plug in the y, you'll do y2 minus y1 over x2 minus x1. And then from a table, okay, you're going to find the rate of change on a specific interval. It'll say from whatever, -1 to 2, you'll go to your box, you'll find whichever ones they want you to find the rate of change on, and you'll do the y minus y2 minus y1 over x2 minus x1. So in those scenarios, it will give you the interval. It might also ask you if it is increasing or decreasing, the rate of change, not the actual graph, but increasing or decreasing, and if it's concave up or concave down. So if my rate of change is positive, that's when it is increasing or concave up. And if my rate of change is negative, that is when it's decreasing or concave down. So for this example up here, my rate of change would be decreasing, and the data would be concave down. Questions so far? All right, then came rate of change at a point. So this was what was not on your quiz, but you will see it on your test. If it says, give me the rate of change at 2x to the third minus 5x, or sorry, give me the rate of change of 2x to the third minus 5x at x equals 2. What do we do with this? Yes, calculator, we're going to plug in what values? Something that's closest. So the one we did together in class was what? Do you remember? 2.001, okay? You can also use 1.999. It doesn't matter. It will give you an approximation that's close enough. But to be consistent, check your answers. It's probably, I think this one used 2.001, okay? So we're going to find f of 2.001 minus f of 2 over 2.001 minus 2. If that was a negative 3, I would do f of negative 3.001 minus f of negative 3 over negative 3.001 minus a negative 3. It doesn't matter. You could go up a little or down a little. It's an approximation of the rate of change because you cannot find a specific rate of change at an individual point. So this is the one we'll come back and do on the calculator if we've got the time, because we'll practice that equation. Questions so far? Dane.
Wait, can I see
Okay, 1, 3 was your rate of change, linear and quadratic. So we still practice rate of change, okay? This time again, they could give you an equation, ask for the rate of change at a certain interval. Or this is where they don't have to give you a specific interval. So it could ask you for the average rate of change from a graph. If it was a line, you literally count the slope, right? So if this is linear, we use the slope. If it's quadratic, we pick points. If it's an equation like y equals 3x plus 2, if it's linear, then my rate of change is what? 3, or 3 over 1, still your slope, okay? If it gave you something like y equals x to the second plus 2x plus 1, now I've got to plug in some points, okay? And this is where we plugged in negative 2, 1, 0, 1, like that. If it wants a specific interval, it will give you this specific interval, okay? But if it wants the rate of change of the rate of change, now we go one more level, okay? So rate of change of, actually it would say average, I think. All the questions say that, but it's the same thing. Rate of change of the average rate of change. Remember, if it's the second level on a linear function, there is no difference. Okay, the rate of change on a linear function is constant. It is always the same value. So if I find the rate of change of that rate of change, it is 0. Save yourself some work. Okay, if it says, but make sure it says rate of change of average rate of change for a linear function, and that is 0. So just one level, just one rate of change, it's the slope, but the rate of change of the rate of change for a linear is 0. The quadratic, the rate of change is going to be different, But the rate of change of the rate of change is going to be the same. And it could be 2, or it could be 3, or it could be 2/3, or it could be anything there, okay? But it is not 0 because, I don't know if that's confusing. The average rate of change has different values. But the rate of change of the average rate of change is constant for quadratic. It is 0 for linear. It is constant for quadratic. But you have to find it. And you have to find it by doing -2, 1, 0, 1. Then find your rate of change. Then find the rate of change of that. Dane.
Could there possibly be a question, like, not on the textbook, but like maybe on the APPC that would like give us like an x cubed or like an x to the fourth, and then ask for the rate of change and the average rate of change of it,
Yeah.
and it would only, like you would only have to go down 1 instead of all the way.
So if it's cubic and you go twice, it's not going to be constant yet. It would give you a specific interval. Or it would ask you, is it increasing or decreasing? It's not going to be the same value.
Yeah.
If it's cubic, you'd have to go to the rate of change of the rate of change of the rate of change for it to be constant.
So if there is a chance that it could ask.
All right, then we got into 1,4. So 1,4 was our polynomial functions and the rate of change. So the easy questions here, identify and don't let it trip you up. Identify your inner or the leading coefficient and degree. Don't always pick the first one. Make sure you look for the highest one, okay? Then it could ask you for local or relative max or min, which is also called the extrema, or it could ask you for global absolute max or min. Remember that local can happen when it's restricted. So if I give you a graph and it's restricted and it says like here and it goes up and it comes back down, it goes back up, it comes back down. If this is an arrow, this does not count as a minimum, but this one does because it's like restricted. It's a point there that would count. So this would be a min. This would be a min. This would be a max. This would be a max.
Relative max?
Those are all relative. Yep, if there's more than one, it's relative. Absolute is just the highest. So absolute, there would be no absolute min on this one because that arrow is going to keep going down to get smaller. Dane.
Are we able to learn like this way, or is there even a way where you could tell us from the equation how many maximums or minimums there are?
You can only know how many max of those you have. Those are your turning points. So you can only know how many maximums there are
From the equation?
from the equation. Yeah, because you don't know if they're real or imaginary. That's how it alters.
So how did you figure that out?
You'd have to find your actual zeros. Yeah,
Oh,
Which-
so that's the 0 thing.
correct. So you'd have to find your zeros, you'd have to know your multiplicity, then you'd know the pattern it takes as it bounces across through, and then from there you could determine the number of them. But just by looking at your equation, no.
It's not gonna ask the things like on the homework where
Wait.
it was like an exception and because it went back down.
It is, but it's straightforward with the zeros. We're going to get there. All right, so that, oh, good segue. Then you got guaranteed extrema, okay? This is where if I have 2 zeros, I know there's guaranteed extrema between there, okay? So if in my, this question had f of 3 equals 0, and it had f of 2 equals 4, and it had f of 0 equals 5, and it had f of, and I'm totally making this up, so it doesn't necessarily have to work, but -1 equals 0, okay? And what we're going to pull from this is where are my zeros? Could I plot that all the way through? Yes, okay? But what I'm really looking for are my zeros, and my zeros are not my y-intercept. I ignore that. My zeros are my zeros, which means my y is 0. And if I have 2 of those, then there is guaranteed extrema, and it is in between those points. So if it says, is there guaranteed, and there's not 2 zeros, then the answer will be no. And if there is 2 zeros, it will be yes. I'm not going to try to trick you where you have to graph it. And the in between would be from -1 to 3. Actually, it would be a parentheses. I think, oh, I got to check my, I don't remember if it's this or if it's in interval notation.
It's
I want to look at the actual test though. I don't think that's multiple choice, and if it's not, I will give you either answer.
Because we switched like.
All right, then we got to if there's an even degree polynomial, if there's an even, and it only works for even degree, if there's an even degree and the leading coefficient is positive, then there's an absolute, or there is an absolute min. And if there's an even degree and it's negative, then there's an absolute max. So those are guaranteed from, again, only even degrees. And then we learned about points of inflection, which we had already used those for your concave up and concave down. We just didn't have a word for them yet. Your point of inflection is everywhere your graph changes from concave up to concave down or concave down to concave up. So if my graph goes like this, I've got concave down, and in here, concave up. So there would be 2 points of inflection there. Dane.
Why did you put LC?
Leading coefficient. Yeah, so positive leading coefficient, my parabola opens up, right? Leading negative, it points down. Still good? Yes? All right, 1-5, polynomial functions and complex zeros. So this is where we started to talk about the number of the zeros equals the degree, but now they can be real and imaginary. So if I have 10, if I have x to the 10th, there are 10 total roots. Some of them can be real and some of them can be imaginary. Imaginary roots come in pairs. So if it says one of the roots is 2 plus 3i, I know the other is 2 minus 3i, and I also know that that means there's 2 imaginary roots. The multiplicity is the number of times a root occurs. And if it occurs an even amount of times, it's going to touch the graph and turn around. Or bounce at that coordinate point or at that 0. And if it's odd, it crosses through. So multiple choice will say touch and turn around. But if you are describing it to me, I will take either of those. Dane.
How do you figure out that if it's even?
All right, then you're going to learn your degree from a polynomial from a table. So you're going to get a table of values. You're going to get your x's. You're going to get your f of x's. You're going to get your values, okay? And you're going to determine if it's linear, quadratic, cubic. It says literally or the degree is 1, 2, 3, I think 4 or other. I can't even remember where I stopped. But I'm just going to find the rate of change first. To begin with, this has to be even intervals. It will be. I'm not going to try to trick you, okay? If it wasn't even intervals, it would be cannot be determined. But it will be even intervals, okay? If the first rate of change, average rate of change, is equal, then it's linear, or n is 1. If the rate of change of that, so I'm going to get a number, I'm going to get a number, I'm going to get a number, I'm going to get a number. If they are all the same, it's linear. Then I find the rate of change of that, and I get a number, and I get a number, and I get a number. And that would make it what? Quadratic, if it is all the same. N equals 2. And then I'd go one more level, another rate of change of that, and I'd get numbers. And if those are the same, then it is cubic, or n equals 3. And if I did it again, so you'd have to have more numbers here. Bad example, because you'd have to have more numbers. And now it's the same. Now it's quartic, or n equals 4. Yeah.
Maybe it's sense that you just keep going into 0 and then you subtract 1 from the amount of.
You can do that, sure. It's just extra work. You have to go one more level. But yes, that's the same thing. And it should work all the way through. So like the homework question we talked about, was that yesterday or the day before? Where you guys got different answers at the end? I went back and redid it. It was all the way through. So when we're done, we'll pull that up. Because it should work all the way through. That was 1, 5, right? Yeah. Remind me, we'll go back to it, okay? Yeah. All right, then even and odd, 2 ways from a graph or from your equation. So if it's from a graph, you're looking to see is it symmetric to the y-axis? And then it would be even. And then symmetric to the origin. And that's odd, or every coordinate point has the opposite. And then from an equation for the y-axis, you're looking for the negative, so f negative 1 of x to go back to f of x. And it happens with things that are even powered, okay? But not everything that has an even power is going to be even. If it says f of x equals x to the 4th plus 2x squared plus x, that's not even. Because it would go away in the x to the 4th, it would go away with the x to the 2nd, but it would stay with the x to the 1st. So this is an either. So be careful. It's not every time there's an even. It's if the only exponents that are there are even. And then odd, if you plug in negative x, you get a negative f of x. So every sign has changed. And this typically happens with odd powers, but again, if only they are all odd. So if f of x equals x to the 3rd plus x, now that's odd. But if f of x equals x to the 3rd plus x plus 1, that's neither.
If it goes back to the original,
It's even. Questions? Yeah.
For both the table and chart, do you want us to write like linear, quadratic?
That one's multiple choice. It'll literally say A, N is 1, B, N is 2, C, N is 3. Yeah.
and is how many times is it?
N is on what level you got to the same number. So if it's the first rate of change, N is 1 because it's linear. If it's the second rate of change, then N is 2 because it's quadratic. How many levels it took to get to the same thing. Yep. All right, and then 1/6 is end behavior, and like obviously, hopefully that was just that one topic, but it could happen from an equation, and it could happen from, it could ask you to draw the graph. You'll see it on the review. But if it's positive and even, what happens to my arrows at the ends? They both go up, and the way we would say that is the limit of the graph as x approaches negative infinity is infinity, good, and the limit of the graph as x approaches positive infinity is positive infinity. Let's not go in order. Let's go down. If it's negative and it's odd, what is my end behavior? Rises left, right? Falls right. So this, the limit of the graph as x approaches negative infinity would be positive infinity, and the limit of the graph as x approaches positive infinity would be good. Go back up to the top. If it's a negative with an even exponent, what's happening? Both are pointing down. Good. Falls left, falls right. So limit of the graph as x approaches negative infinity is negative infinity, and the limit of the graph as x approaches positive infinity, also negative infinity. Last but not least, the odd function with a negative. Huh?
The odd function for the other one was also negative.
They're
They're
both
both negative odd. They're both negative odd.
Oh, did I really? Okay, change this to positive. Thank you. I was like, what did I do wrong? You can change it because you have a note, so feel free to just erase it. Yeah. All right, so if it's positive and odd, what's the end behavior? Falls left, rises right. So the limit of the graph as x approaches negative infinity, the graph is negative infinity, and the limit of the graph as x approaches positive infinity, the graph is positive infinity. Okay, I did make that question multiple choice. I don't need you to spend 15 minutes writing out your answer, okay? Just be really careful because one missed negative all the points. Bye-bye, right? There's no partial credit. So it's not like I can give you credit for one part and not the other. Questions for me as far as expectations. I was saying I'm working on timing on it. I actually want to sit down and take it, and then I will be able to tell you exactly how many questions and stuff on Monday. There is going to be a calculator portion and a non-calculator portion. You'll start with the calculator portion. Speaking of, we can go back up to that question and we can do that one so that we can practice with our calculators. Alba.
Yeah.
Start recording. All right, so in order to find this, I typed into my y equals the equation 2x to the third minus 5x. Then I'm going back to my home screen, and I'm going to do this entire thing in one move, okay? So if you do, everybody's different, but mine is under alpha y equals. My alpha y equals is my ND. Remember, you also could have a shortcut. I'm going to do the the alpha trace button brings my y1. y1, open the parentheses, 2.001, close the parentheses, minus, I'm going to go back there, alpha trace, y1 again, open my parentheses 2, close my parentheses, over 2.001, minus 2, hit enter, and there's my answer. I cannot stress enough that if you are just giving me that answer and there's no work and you get a little bit of it wrong, I can give you no credit. So my advice is to at least write out what you wrote in your graphing utility so that I know what it is, especially if you're not using 2.001, which I would recommend, but you could still get it right by using 1.999. It's still the same, right? It's still a rate of change as close as we can get it, but it's not going to be exactly the same. So make sure you're writing what you're typing in your calculator. To tell you, from here on out, we said we're going to round this to the 100th place or 3 decimal places. So that would be 19.012. Huh? What did I say? No, thousands. 3 decimal places, thousands.